Hello friends, welcome to Muro Maths. Today let us discuss a problem from Fourier Series from the unit TPDE. Question is, express f of x is equal to pi minus x the whole square as a Fourier series of period 2 pi in the interval 0 less than x less than 2 pi. Hence deduce the series 1 plus 1 by 2 square plus 1 by 3 square etc. It goes on. Right. So question is to find Fourier series. That is, we have to express the given function pi minus x the whole square as a Fourier series, and the limit of the variable x is 0 to 2 pi. Period is 2 pi and the interval is 0 to 2 pi. So solution. So given f of x is equal to pi minus x the whole square and the limit of the variable x is 0 less than x less than 2 pi. Right. We know that Fourier series is given by f of x is equal to, here it is full range and it is general Fourier series. So f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. If the limit is given in the form of pi, then the Fourier series is given by a naught by 2 plus summation an cos nx plus summation bn sin nx. Whereas instead of pi, if the limit is given in terms of L, either that may be L or L may take some values 0 to 1 or 0 to 2 or 1 to 2, any values minus 1 to 1, minus 2 to 2, any numerical values, then the formula to find Fourier series becomes a naught by 2 plus summation an cos n pi x by L plus summation bn sin n pi x by L. Right. Now the Fourier coefficients a naught, an and bn are given by, implies a naught is equal to 1 by pi integral 0 to 2 pi f of x dx. An is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx, and bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. And here a naught is nothing but putting n is equal to 0 gives a naught on both sides. In the result of an, in the formula of an, when we put n is equal to 0, we get the formula to find a naught. Putting n is equal to 0 on both sides here. Cos, when we put n is equal to 0, here it becomes cos 0 and cos 0 is 1, and that is how we got this formula to find a naught. 1 by pi 0 to 2 pi f of x dx. Right. Now the first Fourier coefficient a naught. A naught is equal to 1 by pi 0 to 2 pi f of x is given by pi minus x the whole square. Pi minus x the whole square dx, which is equal to 1 by pi. Either we shall expand this in the form of a minus b the whole square. After expanding it, we shall integrate it, or else we shall integrate it directly like pi minus x the whole cube by 3, and the coefficient of x is minus 1, so minus 0 to 2 pi. Considering this as some capital X square, integration of x square is given by x cube by 3. So pi minus x the whole square becomes pi minus x the whole cube by 3, and the coefficient of x is minus 1, so minus 1 has come in the denominator. Limits 0 to 2 pi, which is equal to 1 by pi, raising upper limit 2 pi to the variable x. So pi minus 2 pi is minus pi. So minus pi the whole cube by minus 3, upper limit, minus of lower limit. Already we have a minus here. So minus into minus plus 0. X takes the value 0. So it is just pi cube by 3. Right. Upper limit 2 pi to the variable x. So pi minus 2 pi is minus pi the whole cube, and this minus 3 has come as it is here. Upper limit minus of lower limit. So minus of minus has become plus here. And 0, x takes the value 0. So it is just pi cube by 3. Now this, this is again 1 by pi. This minus pi, the whole cube is nothing but minus pi cube. Minus 1, the whole cube is minus, and pi cube is pi cube. By minus 3 plus pi cube by 3. This minus is cancelled, which is 1 by pi, 2 pi cube by 3, which is nothing but 2 pi square by 3. That is A naught is equal to 2 pi square by 3. A pi is cancelled. So here it becomes 2 pi square. So 2 pi square by 3. A naught is over. Next is an. An is equal to 1 by pi integral 0 to 2 pi. Function is pi minus x the whole square cos nx dx. Right? So integration of this term, product of this and this, algebraic function along with trigonometric. So to integrate and find the value of this integral function, that is the product of algebraic and trigonometric, we have a formula. That formula is Bernoulli's. Bernoulli's formula is given by integration of u dv is equal to uv minus u dash v1 plus u double dash v2 minus etc. It goes on. Right? uv starting with plus. It starts with plus, alternative plus and minus, it goes on. Plus uv minus u dash v1 plus u double dash v2 minus u triple dash v3 etc. It goes on. Alternative plus and minus. And u should always be the algebraic term. So u is equal to pi minus x the whole square, and dv is given by rest of the term cos nx dx. Right? So from this v is equal to integration of cos nx. Integration of cos nx plus sin nx. Sin nx by n. So u dash is 2 into pi minus x, and the coefficient of x minus 1 comes here in the product. Then v1 is integration of sin is minus cos. So minus cos nx by n square. Already we have a n. So one more n becomes n square. Then u double dash. U double dash is minus 2 pi. When we differentiate pi, it becomes 0. Differentiation of minus x is minus 1. So it becomes plus 2. So v2 is equal to minus integration of cos is sin nx by n cube. Once again, if we take u triple dash, this constant becomes 0. So after that, all the differentiations become 0. That is why we stop with this. And that is why we consider the algebraic term always as u. Because algebraic term, when we differentiate the algebraic term, after certain differentiations, it becomes 0. Right. Now, an is given by an is equal to 1 by pi uv minus u dash v1 plus u double dash v2. So pi minus x the whole square sin nx by n minus 1, 2, 3. So minus 2 pi minus x cos nx by n square. Then we have minus 2 sin nx by n cube 0 to 2 pi, which is equal to 1 by pi, raising upper limit 2 pi to the first term, whereas we have a sine term here, sine term, and we know the result. Sin n pi is equal to 0, which means sin 2n pi is also equal to 0. Right? So this term becomes 0, first term. Sin 2n pi becomes 0. X takes the value 2 pi. So overall this is sine 2n pi. It becomes 0 for all values of n. For all values of n, that is n is equal to 0, 1, etc. It goes on. 2, etc. It goes on. Etc. It goes on. Right. Then second term. Second term we have minus 2 here. Minus 2. X takes the value 2 pi. So pi minus 2 pi is minus pi. So plus pi cos 2n pi. In general, cos n pi is minus 1 whole power n. So cos 2n pi is nothing but minus 1 whole power 2n, which is nothing but minus 1 whole power n the whole square. And this is nothing but plus 1 always. So cos 2n pi is plus 1. So this becomes 2 pi by n square. X takes the value 2 pi. This minus 2 has come as it is. X takes the value 2 pi. Pi minus 2 pi is minus pi. So minus into minus it becomes plus 2 pi. Cos 2n pi value is plus 1 by n square. Right. And again the third term is in sine. Sine of 2n pi is 0. So it becomes 0. So upper limit is over. Now minus of lower limit. Lower limit is 0 and again sine 0 is 0. Next term, this one. Minus of lower limit. So minus into minus plus here. Plus x takes the value 0 and cos 0 is 1. Cos 0 degree is 1. Cos 0 is 1. So minus into minus of minus plus 2 pi. 2 pi by n square. Right? Which is equal to 4. 1 by pi. 4 pi by n square. This pi is cancelled. An is equal to 4 by n square. An is also over. Next, Bn. Bn is equal to 1 by pi integral 0 to 2 pi f of x is pi minus x the whole square sine nx dx. Right? And always algebraic term is u, rest of the term dv, applying the same Bernoulli's formula. So u is equal to pi minus x the whole square, right? dv is equal to sine nx dx. v is equal to minus cos nx by n. U dash is equal to 2 into pi minus x minus 2. V1 is equal to minus sine nx by n square. U double dash is equal to, we have it as plus 2 here, same comes here also. V2 is equal to minus sine, integration of sine is minus cos. So plus cos nx by n cube. Right. So Bn is equal to 1 by pi uv minus u dash v1 plus u double dash v2. So uv, we have a minus here, minus pi minus x the whole square cos nx by n. Then 1, 2, 3 minus are there. So minus 2 into pi minus x sine nx by n square plus 2 cos nx by n cube, 0 to 2 pi. Now raising the limits, which is equal to 1 by pi, raising upper limit 2 pi to this term, right? So pi minus 2 pi is minus pi the whole square. Minus pi the whole square is plus pi square, whereas we have a minus here. This minus comes as it is. So minus pi minus 2 pi is minus pi the whole square is pi square. Pi square, then cos 2n pi is plus 1. So 1 by n. Second term is in sine. Sine of 2n pi is 0. So it becomes 0. Then the third term. Third term is again cos 2n pi is 1, just 2 by n cube, plus 2 by n cube. So plus 2 by n cube, upper limit is over, minus of lower limit. So minus, this term becomes plus, right? So plus, x takes the value 0 and cos 0 is 1. So just plus this pi square by n alone. Pi square by n. Then the second term. Second term, when we put x is equal to 0, sine 0, it becomes a sine 0 and sine 0 is 0. So the second term becomes 0. So moving on to the third term. Third term, cos 0 is 1. Upper limit minus of lower limit. So here it becomes minus cos 0 is 1. So it is just minus 2 by n cube. Minus 2 by n cube. So minus pi square by n plus pi square by n. 2 by n cube minus 2 by n cube. So overall bn is equal to 0. There is no bn for this function for the given limits. Right. We have completed finding all the Fourier coefficients a0, an and bn. Now applying it in the Fourier series formula. In the Fourier series formula, let this be equation number 1. Now equation number 1 implies f of x is equal to, it is a0 by 2, where a0 is 2 pi square by 3. So a0 by 2 is just pi square by 3. So pi square by 3 plus summation n is equal to 1 to infinity an. an is 4 by n square. So constant 4, putting it outside of summation, by n square, 1 by n square cos nx plus summation n is equal to 1 to infinity, bn is 0. So we shall omit this 0, right? Implies f of x is equal to pi square by 3 plus 4 summation n is equal to 1 to infinity cos nx by n square. This is the first part, finding Fourier series. So first part is to find Fourier series and we have completed finding Fourier series. Fourier series is over. Next, hence deduce the series 1 plus 1 by 2 square plus 1 by 3 square, etc. It goes on. So if we have deduction part, maybe if there is no deduction part and the question is to find Fourier series alone, we shall stop with this. Instead, if we have deduction part, let us expand this and write it. So f of x is equal to pi square by 3 plus 4, giving values for n 1 by 1, starting from 1. 4 into, first n takes the value 1, cos 1x, cos x by 1 square, plus n takes the value 2, so cos 2x by 2 square, plus x takes the value 3, so cos 3x by 3 square, plus etc. It goes on, right? Now comparing this along with the given series in the question. So it is just 1 by 1 square, 1 by 2 square, 1 by 3 square, etc. Right? Whereas here also we have the same terms, 1 by 1 square, 1 by 2 square, 1 by 3 square. But along with that, we also have the cos terms, cos x, cos 2x, cos 3x, etc. So we have to make those cos terms as 1. When we take cos terms as 1, we get the same series exactly what is given in the question, right? So when we put x is equal to, so we have to check which value is suitable for x, such that when we put that value for this cos terms, those cos terms should become 1. Those cos terms should become 1, right? The given limit of the function is 0 to 2 pi. So we have to choose any value for x from this limit such that all those cos terms become 1. When we take x is equal to 0, all the cos terms become 1, right? Cos 0 is 1. So put x is equal to 0, in the series, right? Put x is equal to 0. When we check x is equal to 0 is a point of discontinuity. Discontinuity. Because 0 less than x less than 2 pi. Maybe if it is a 0 less than or equal to x, if it is 0 less than or equal to x, in that case x is equal to 0 is said to be continuity, is continuous. But here it is just 0 less than x. In such case x is equal to 0 is said to be discontinuity. So in that case LHS is given by f of 0 plus f of 2 pi by 2 is equal to pi square by 3 plus 4, 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus etc. It goes on. Putting x is equal to 0 on both LHS as well as RHS. And in the case of LHS, if the case is discontinuity, this is the procedure to find the value for the function f of x. Right. Now f of 0. F of x is pi minus x the whole square. So f of 0 is putting x is equal to 0. So it is just pi square. So pi square plus f of 2 pi. F of 2 pi. When we put 2 pi, pi minus 2 pi is minus pi. Minus pi the whole square is pi square. So pi square by 2 is equal to pi square by 3 plus 4, 1 plus 1 by 2 square plus 1 by 3 square plus etc. And we need the value of this series. We have to deduce this series. So let us take this series in the LHS. Implies 1 plus 1 by 2 square plus 1 by 3 square plus etc. is equal to, this term remains as it is. This is nothing but 2 pi square by 2, which is nothing but pi square. Right? Pi square. Right? This pi square by 3, when we take this pi square by 3 to the other side, it becomes minus pi square by 3. So minus pi square by 3, right? And this constant 4, which we have in the product along with this series, when we take this 4 to the other side of the equation, it becomes division 1 by 4, right? Which is equal to 3 pi square by 3 into 4. This 3 is cancelled. Sorry, 3 pi square minus pi square. 3 pi square minus pi square by 3 into 4, which is equal to 2 pi square by 12, right? Which is equal to pi square by 6. This is the required answer. Thank you friends. Let us meet in another problem.